So now that we've gone over average velocity, the next thing to talk about is instantaneous velocity. Instantaneous velocity. Now throughout this semester we're going to develop skills to actually compute the instantaneous velocity, but for right now we can estimate it. So what is the instantaneous velocity? Instead of saying over an interval, what's the average velocity, I'm saying at a particular time. So this question will be worded kind of like, at t equals something, what is the velocity? So when we were doing average velocity, we were given two t values. So we would subtract the two positions divided by the change in the two times. But now what happens if we're just given we want to find the instantaneous velocity at a point. We don't have another point to use. So for now, what we're going to be able to do is to estimate. And here's how you estimate. You'll let T1 be your A, and then you'll let T2 be really close to A. And then you'll find the average velocity. Then find average velocity. So let's do an example here. Let's say position is given by S of t. I'm going to use 4.8 t squared plus 1, and this is measured in feet. And I want to estimate the instantaneous velocity, which I'm just going to say the velocity, at t equals 3. So this is not asking for average velocity. Average velocity, they would give you two time numbers. Here they didn't, they just gave me one. So what I'm going to do is I'm going to let T1 be 3. Right, so I said that if you want to estimate, you let T1 be the point that they give you. And then I'm going to let T2 be something really close to that. So let's say 3.1. That's relatively close. What's the average velocity? So this is going to be my first attempt. Let's find the average velocity. It's going to be S of 3.1 minus S of 3 divided by 3.1 minus 3. Now you can plug this into your calculator. I believe you will get 29.28. Was that the best estimate that we could have made? Well, no, I could have chosen my T2 to be much, much closer. So let's try to make a better estimate. Let's let, again, my T1 be 3, but this time let's let T2 be 3.01. So that's much closer to 3. This time, what do I get for the average velocity? I get S of 3.01 minus S of 3 divided by 3.01 minus 3. Plug that in, you get 28.848. Again, how am I finding these numbers? I'm just plugging these into my formula. So this is a better estimate because I was closer. The T2 was closer. Let's do one more. This time I'll let T1 be 3, but let's get even closer. What's my T2 going to be? How about 3.001? So that one's even closer than the estimate I made before. Now the average velocity is going to be S of 3.001 minus S of 3 divided by 3.001 minus 3. Plug that in, you're going to get 28.8048. So let's look at those three numbers. What we have here. The first time I did it, and this was my worst estimate, I got 29.28. Second time, this is my second best estimate, I got 28.848. Third time, I got even closer to my original T, and I got 28.8. Does it look like, as my estimate gets better and better, does it look like these numbers are going to something? I think that we can see that they are kind of going to 28.8. So our estimate would be that the instantaneous velocity at t equals 3 is approximately 28.8 feet per second. So again, how did we do that? The original problem only gave you one value, only one t value. So we estimated. Now our first estimate wasn't very good. I was only 0.1 away from my second t was only 0.1 away from my original t, but I plugged it into my average velocity formula and got 29.28. Then I made a better estimate. I got 28.848. Then I made an even better estimate and I got 28.8048. So it looks like these numbers are going towards 28.8. Now I could have done this again for 3.0001 and seen what that one was, but I think we can say it's safe to assume that the approximate instantaneous velocity is 28.8 feet per second. So for instantaneous velocity, pick numbers that are close to my original t and then plug them into the average velocity formula.